All right, so for number 5, we're given this function, f of x equals e to the x times cosine of x. Find the average rate of change of f on the interval 0 to pi. All right, average rate of change means slope. So we're going to get a point for 0 and a point for pi, and then just do the slope. All right, so if we plug in 0, e to the 0 power is 1. Cosine of 0 is also 1. If you look at your unit circle, 0 pi is right here. Cosine is the x value, so that is 1. Right, so if you plug in 0, you get 1. If you plug in pi, you're going to have e to the power pi, and then times cosine of pi. So pi is right here. Again, cosine is the x value, so that would be -1. So that would be e to the pi times -1. So negative e to the power pi. And then all you have to do is the slope. Again, average rate of change means slope. So negative e to the pi minus 1 over pi minus 0. And that is your answer. So average rate of change means slope. We just got the 2 points and did the slope. All right, part B. What is the slope of the line tangent to the graph of f at x equals 3 pi over 2? All right, slope of a tangent line means derivative. So we're going to get the derivative, and then we're going to plug in 3 pi over 2. So this is going to be a product rule. Our first function is e to the x. Our second function is cosine. So product rule is the first function times derivative of the second. So derivative of cosine is negative sine, plus the second function times derivative of the first. And e is its own derivative, so that's just e to the x. And then plugging in 3 pi over 2. Now, I like for you to be able to evaluate the trig, but technically for free response, you don't have to evaluate it. Now, you would need to know how to do sine of 3 pi over 2 and cosine of 3 pi over 2 for a multiple choice question. You'd have to be able to get through that, but technically they can't fault you if you just plug in 3 pi over 2 for all those x's. So if you're unsure, just leave it, because they would have to give you credit. All right, part C, find the absolute minimum value of f on the interval 0 to 2 pi, justify your answer. This is another candidates test. Are you guys seeing how the same things tend to show up over and over again? They love this candidates test. All right, so your candidates, and we're going to plug into the original function here. Your candidates are the endpoints 0 and 2 pi, and then the critical points. So critical points come from derivative equals 0. I put it over the paper. We already have the derivative. It's right here. We want to set this equal to 0. I'm going to factor out an e to the x because that'll make this a little bit easier. We're going to set the derivative equal to 0, and our derivative is right here. So if I factor out e to the x, I'll be left with negative sine of x plus cosine of x. And again, equal to 0 to get our critical points. So e to the x is never going to equal 0. That's a swoopy shape with an asymptote at 0. It's never going to touch 0. So don't worry about that one. Just look at this one. I'm going to add over the sine of x. So we're looking for a place on our unit circle where cosine and sine are equal. That happens at the pi over 4 mark, because at pi over 4, both of the sides of your triangle are root 2 over 2. So sine is root 2 over 2 and cosine is root 2 over 2. So that's one of our critical points, is pi over 4. But the other one, because there's going to be a second one, is in the third quadrant, because both of the sides are negative root 2 over 2. So they're still the same. They're just both negative. And to rotate that far, that is 5 pi over 4. All right, so those are our critical points. 0, pi over 4, 5 pi over 4, and 2 pi. We're going to plug into the original equation, which is right back up here. So e to the 0 is 1, cosine of 0 is 1. So that's just going to give us 1. If we plug in pi over 4, you'll have e to the power pi over 4 times cosine of pi over 4, which is square root of 2 over 2. You can leave it as cosine of pi over 4, that's fine, but we have to know which one of these is the biggest and which one is the smallest. All right, e to the power 5 pi over 4, whatever that is, times cosine of 5 pi over 4. Now that's negative root 2 over 2. So again, you can leave it as cosine of pi over 4, but you still need to know that it's negative, because again, we have to figure out which is the biggest and which is the smallest. All right, and then if you plug in 2 pi, e to the 2 pi times cosine of 2 pi, which is the same as cosine of 0, which is 1. So that would just be e to the 2 pi. All right, let me see. Did they ask for the minimum or the maximum here? Find the absolute minimum value. All right, so the absolute minimum is, it's going to be this one because this is negative. E to the 5 pi over 4 times negative square root of 2 over 2 at x equals 5 pi over 4. And again, I just want you to be in the habit of writing the whole statement. Sometimes they ask you for the minimum. Sometimes they ask you for the, usually it's time, but the x value. And sometimes they ask you for both. So just get in the habit of writing the whole thing, and then you'll always get it. All right, and then the last one, putting this graph in here, that's the graph of g prime. All right, let's get this one first. Let g be a differentiable function. All right, so that's probably going to come up at some point. Such that g of pi over 2 equals 0. The graph of g prime, the derivative of g is shown here. Find the value of limit as x goes to pi over 2 f of x over g of x, or state that it does not exist, justify your answer. Right, this is going to be L'Hopital's rule. If you plug in pi over 2 to each of these, you're going to get 0 over 0, just as a foreshadowing thing here. So you have to show them separately because you can't write that something equals 0 over 0. So I'm going to do limit as x goes to pi over 2 of just f of x first. And then I'm going to do limit as x goes to pi over 2 of g of x separately. All right, so here is f of x. If we plug in pi over 2, we're going to have e to the power pi over 2 times cosine of pi over 2. And pi over 2 is right here on your unit circle. Cosine is the x value, so that is 0. All right, so that limit is going to go to 0. All right, then for g of x, we plug in pi over 2. It tells you right here, g of pi over 2 is 0. Now, this is a little bit silly here, but they want you to mention that the reason you can set the limit equal to the point is because the function is continuous. So I'll turn right up the middle step. So this limit equals the point, which is 0, since g of x is differentiable and continuous. They mention it's differentiable, so you just want to say that that means it's also continuous. And that means you can set the limit equal to the point. All right, so the whole point of all that is you're showing that this goes to 0 over 0. The numerator went to 0 and the denominator went to 0, so that whole thing is indeterminate. So we're allowed to use L'Hopital's rule. So limit as x goes to pi over 2 of f of x over g of x is going to be equal to the limit as x goes to pi over 2 of f prime of x over g prime of x. This is showing L'Hopital's rule. You have to write that out to get the point. That's what L'Hopital's rule means, is that you can take the derivative of the numerator and the derivative of the denominator as long as both of these go to 0. As long as you have an indeterminate, you're allowed to do that. All right, then the last thing here is to evaluate this. So f prime of pi over 2, we're plugging in pi over 2. We have f prime somewhere here. I know that we found it. Oh gosh, it's way back up here in part B. Here's our f prime. We're going to plug pi over 2 into that. So that is going to be e to the power pi over 2 times negative sine of pi over 2. And again, you don't have to evaluate them for your response. Times cosine of pi over 2 times e to the pi over 2. All right, so I plugged pi over 2 into f prime, which was this right here. And then in the denominator, g prime of pi over 2, they gave us g prime in this graph. So g prime of pi over 2 is 2. And it doesn't matter that there's a sharp edge there. We're just looking for that point. It's just what is g prime of pi over 2, and we get 2. So 2 for that denominator, and then this is your answer. All right, so points for this. In letter A, you just get a point for the answer, but all you had to do was a slope, so that's fair. All right, in part B, it is a point for the derivative and then a point for the answer. That's fair too. All right, and then in part C, you get a point for setting the derivative equals 0. So if you even said f prime equals 0, you would get that point. You get a point for finding these two critical values. Let me see, and then you get a point for your answer. Okay, yeah, that's all you got for that one. All right, and then in part D, you get a point for doing L'Hopital's rule. So if you wrote that, if you wrote the limit is x goes to pi over 2 f of x over g of x equals limit is x goes to pi over 2 of the derivatives, you got a point for knowing L'Hopital's rule. You get a point for showing that this limit equals 0, and you have to mention that the function is continuous. Since it's differentiable, it's also continuous. That's not sure I 100% agree with that, but I'm just letting you know that's what it is. And then a point for the answer. Let me make sure I didn't miss any. Yes. All right.